Seismic waves are useful in determining the location of earthquakes. More importantly, seismic waves provide a tool for probing Earth's interior.
When locating an earthquake on a map, seismologists plot the epicenter, the point on Earth's surface directly above the focus. The difference in the velocities of P and S waves provides a method for locating the epicenter of an earthquake. The farther away the recording instrument is from the focus, the greater the difference in arrival times of the first P wave compared to the first S wave. How many minutes separate the arrival of the first P wave and the first S wave? To determine the distance between a recording station and an earthquake epicenter, seismologists use a travel time graph. Time is the difference between the arrival of P and S waves. When the first P wave arrives 4 minutes before the first S wave, the earthquake occurred kilometers from the recording station. Using seismograms from 3 recording stations and a travel time graph, we can establish the location of the earthquake epicenter. How far is the epicenter from a recording station located in Nagpur, India? From this information, we conclude that this earthquake occurred somewhere along a circle centered around Nagpur with a radius of 3,400 kilometers. Next, determine the distance from the earthquake to a seismic station located in Darwin, Australia. Drawing a circle with a radius of 4,900 kilometers centered on Darwin, we see that the earthquake must have occurred at one of 2 sites. Now determine the distance from the earthquake to a seismic station located in Paris, France. With this final piece of data, we conclude that the earthquake occurred in northern China. By establishing the locations of thousands of earthquakes, seismologists have determined that these destructive forces are concentrated along a few narrow zones. The greatest number of earthquakes occur near the outer edge of the Pacific Ocean in a region known as the Circum-Pacific Belt. This area of the globe contains many of Earth's convergent and transform fault plate boundaries. Another belt extends through the world's oceans along the oceanic ridge system. Why are most earthquakes generated along plate margins? About the same time that the basic outline for the theory of plate tectonics was being formulated, seismologists demonstrated just how well the plate model accounted for the global distribution of earthquakes. In particular, seismologists were able to explain the close association between deep focus earthquakes and oceanic trenches. Based on our understanding of the mechanism that generates earthquakes, one would predict that earthquakes should only occur in Earth's cool, rigid, outermost layer. Here, as rock is deformed, it bends, storing elastic energy like a stretched rubber band. Once the rock is strained beyond its breaking point, it ruptures, releasing the stored up energy as the vibrations of an earthquake. The hot, mobile rocks of the asthenosphere are not capable of storing elastic energy and therefore should not be capable of generating an earthquake. Nevertheless, earthquakes having depths of nearly 700 kilometers are known.